Hi, academic stars around the world. Welcome back to Caltex Academy. In case you're new, my name is Julius, and thank you for clicking on this video. Today on our board, we have distance in nautical miles. In our previous videos, we look at calculations of earth geometry of distances in kilometers. So before we look at an example, we're going to have some small introduction here. And when you take a look at our diagram here, we have this point P and point Q. So when we join these 2 points together, we have that distance. So from our definition, we say a nautical miles is the distance on a great cycle which subtends an angle of 1/60 degrees at the center of the Earth. So this distance, if we subtend an angle of 1/60, we'll have, of course, our center here, O, and the distance O, P, is the radius, R, and also this is OQ, radius, R. Now, we can go ahead and have this great cycle maybe illustrated here. So this is the latitude at 0 degrees. So when you look at this diagram, there are two important key points we need to talk about here. One is we need to get the circumference of any great cycle, could be this longitude one or the latitude, or in a slanting way in nautical miles. And the second one also, we need to look at the radius of the Earth in nautical miles, because the questions will require especially the radius. And when we calculate questions that require radius, then pi also will be involved, and the value for pi is, in most cases, 3.142. So we have to take note of that. So let's start with the circumference of the circle. Now, circumference of a circle in terms of degrees, it's 360 degrees. And from our definition here, we say 1 nautical mile is equivalent to our angle here, that is 1/60 degrees. So if we have C as our circumference and is equivalent to 360 degrees, and we cross multiply, you realize that C will multiply 1/60, and we obtain C/60 equivalent to 1 times 360, it remains 360 degrees. So the next thing is we can multiply both sides of this equation by 60, because we need to find only our C alone from here. So the 60 from the left-hand side will cancel, and we're only left with the value of C, as when we multiply these two numbers, we get 21,600. And of course, the result here is in nautical miles. We can see this value of C is having this unit here. So our unit is in nautical miles. So that is one note. And the second one is about the radius. And how do you get radius? So radius can be calculated from the formula of circumference of a given circle. When you have a circle, like assuming this is our great cycle, the diagram is not accurate, but don't worry about that. And we have a radius r, and we're expected to get the distance around here. We know that circumference of a given cycle is given by twice pi r. So from here, our main interest is to make r the subject. So if you divide both sides by 2 pi, we'll obtain the circumference c over 2 pi. So from here, we can make some substitution to the formula here, and we have c is what we have gotten here, and that is 21,600 all over 2 times the value of pi, which we quoted earlier on as 3.142. Now our radius of the Earth in that great circle is given by, when you divide this number, we'll get a result of 3,437.301,082. Now let's round this to the nearest whole number. So our R is given by 3,437 in nautical miles, and that becomes our radius of the Earth in nautical miles. And the reason why we have done this is because we'll meet all this number in questions that requires us to calculate distances between any 2 points on the Earth's surface. And for you to get aware that, okay, this 3,437 comes from this basis. And by the way, you need to take some notes. If not, don't worry. I prepared some cheat sheet PDF that you can download from the link in the description of our video here. And also you can even print it out, so you don't have to worry about taking notes. So with all these bases, let us move on and look at our example number 1. I've prepared for you 2 questions for this video. So let's get example number 1. In our example number 1, we have this diagram of the globe of Earth. So let's read the statement to understand exactly what is happening in the diagram. So it says, an aircraft left town A for town B, traveling along the longitude 42 degrees east, and this is the longitude 42 degrees east. You can see it is in this part of the hemisphere. Calculate the distance between A and B along the cycle of longitude in nautical miles. So how do we tackle this question out? Now, for us to tackle this question out, we need to spot the angle difference between point A and point B. So let's also have a sketch of this same diagram down here for us to make our drawing. Yep, so from here, we can see that the 2 points or 2 towns A and B are all located in the northern hemisphere. And if they are always in the same hemisphere, what we do is we get the angle difference by subtracting the small angle away from the bigger angle. So before we do that, let's illustrate it on our diagram by joining point O to A. Let's also join point O to B. So the angle difference is this angle here between the substance of angle from A and B to the center, and these 2 red lines are the radius of the Earth here. Now, we are required to calculate the distance between point A and B is this arc here. So let's move on and quote our formula. But before we quote this formula, we first need to get this angle difference. Remember, if we join this point to this latitude at 0 degrees east, you see that all the measurement of these angles are from here, and that is the degrees given here as 26 degrees. And the next measurement is from here up to there, and that is 35 degrees. So maybe I can bring it out here as 35 degrees. So for us to get this theta, we need to subtract this small angle 26 away from this one to be able to get only theta here. So let's go ahead and do that by letting our angle between the two towns at theta as it appears in the diagram here, and we have it as 35 degrees minus 26 degrees. So if we subtract this, we get 9 degrees. So after that, we can quote our formula for getting the angle of this arc. Remember this arc, just something like that, where our upper part here is the A, that we can join it to the center, and our center here is O, with our theta here, which is 9 degrees. Now this one is the radius of the earth, and we're given the radius of the earth in nautical miles as 3,437. Now, since it is a minor sector, we can get this small angle and put it over the center degrees and multiply by the area of getting circumference of a given circle, because we know that this circle will have continued like that here. Now, this is not our concern. Our concern is only this small distance that move from this point A to point B. And of course, our point B is here. Now, let's go ahead and quote our formula saying our arc AB is given by the center degrees. And there are two ways of quoting this formula. One, you can use 180 degrees from the denominator, and you multiply it by pi r as the radius of the earth. Now, if you wish, you can also have it in terms of theta over 360, but remember to put it all as if you're quoting the formula of getting the whole circumference. So 2 pi and r. So I think this one is more simplified than the other one. I'm going to continue with the first formula here. Now tell us in the comment section which one do you prefer, this one or the other one. So we have here 9 degrees over 180 degrees. By the way, we are solving here part A of the question. So let's number it, and we're multiplying it by pi, and pi is given by 3.14, and 2 times 3,437 as stated here in nautical miles. Now let's enter this into a calculator and get the results here. So we have 539.9527. So we can round it maybe to 2 decimal places. Since we have not been restricted to any, we are free to select either in decimal places or in significant figures. So here I've selected to be decimal places, at least 2. So we have 539.95. Since 2 is smaller, cannot round upwards, so it rounds downwards, and we have the distance in nautical miles between the two towns A and B. If you enjoy this video, please go ahead and subscribe to the channel, and that is another one way of motivating me to produce these videos with even PDF that are free. You can print and file it for your preparation, either for examination or you're passionate about maths. So continue supporting me by subscribing to the channel, share the videos with a friend. Remember, sharing is also hearing. So with all this said, let's move on and look at part B of the question. So in part B of the question, it says if it took 3 hours to travel from point A to town B, calculate the speed in knots to the nearest whole number. Always, if the distance is in nautical miles, then the speed should be measured in knots. Now, part B of the question, we have our distance, which we have just calculated it here, and it's good to always quote the distance in its original format. Remember, it was 539.9527. Now, the time, according to the question, is 3 hours. And we're expected to get the speed in nautical miles. So this speed is what we're looking for. Maybe we can represent by question mark. Now, after this, we can quote from the formula. Speed is given by distance divided by time. Now let's make substitution to our formula. So our distance is 539.952 divided by time, 3 hours. So this one gives us 179.98527. So we can round this to whole number because you can see these numbers are bigger enough, like 98. So we can round it to a whole number. Therefore, our speed is approximately to 180 knots. And that is the answer for question 1. So again, let's move on to the next question 2. All right, in question 2, it says point A is on latitude 30 degrees north and point C is on latitude 72 degrees south and on the same longitude 42 degrees east. Use the information above to sketch the Earth and show point A and C on the globe. Now I've sketched some diagram here. We just need to follow and locate exactly where these points are. So when you look at this, we have this globe, and remember we have a common longitude here. Now maybe we can label it with the degree given here. Remember, the degree given for this longitude is in the eastern hemisphere, and it was represented by 42 degrees east. So let's label it as 42 degrees east. And this point here is in the southern part, and remember we're told that it was point C. So the latitude was 72 degrees in the southern hemisphere. And again, this one is in the northern hemisphere and it has a degree of 30 degrees north. Now this is 30 degrees north and this is point A. And the distance we're expected to work on is this arc that is moving from A through the latitude 0 degrees here. Remember, this one is 0 degrees. And the center of this Earth is here, O. Now, we need the angle difference. So for us to get the angle difference, we also need to join point O to A. We also need to join point O to point C. All right, so this angle difference, theta, is located between these 2 points that are in different hemispheres, that is the northern and the southern hemisphere. So what we have to do for us to get this angle difference, we have to add these 2 angles together. So theta is given by 30 degrees plus 72 degrees. Therefore, when you add them together, you get 102 degrees. So again, we can go ahead and quote our formula. and make substitution to our formula, maybe down here. So our distance is the arc AC given by theta over 180 times pi r. Now on substitution, our theta is 102 over 180, and we multiply by the value of pi, that is 3.142 times the radius of the earth in nautical mile, and that is 3,437. So let's get our calculator, insert everything to obtain our answer. So maybe we get some space here. So we have 6,119.463,933. So we can go on and approximate our results to 3 significant figures. So let's move on and make our answer to 3 significant figures. Therefore, this approximate to 1, 2, 3. We normally start counting from here, and this is 9, so we can round it upwards, and we have 6,120, and that is in nautical miles. And that is the answer for part B of the question. Again, let's look at part C of the question and see what it says. So in part C of the question, it says an aircraft left town A for town C at 20 hours and arrived at 23 hours. Calculate the average speed. Take pi as 3.142 and radius of the earth as 3,437 nautical miles. So for us to get the time, we need to subtract the arrival time minus the departure time. So our distance is already here. It's good to take this without rounding for us to minimize errors. So part C of the question were to get speed, average speed, which is not known here, and the distance is already known to be 6,119.463,933. So time is the difference of the arrival time, and that is 23 hours minus the departure time, which was 20 hours. These measurements are in 24-hour system, so we have a difference of 3 hours. So we know our time, we know our distance, we can get our average speed. Therefore, average speed is given by total distance divided by total time. So our total distance is 6,119.463,933. We divide it by our time, that is 3. So if you input this on your calculator, we get the average speed as 2039.821,311. So we can approximate our average speed to a whole number by rounding 8 to the nearest whole number here to obtain 2040. And the average speed is also measured in knots because our distance was in nautical mile. So this becomes our average what? Speed. And this is the solution to part C of the question. Thank you very much for watching. If you have gotten some good value from this video, please leave a like, share with friends. And if you have not subscribed to the channel, what are you waiting for? Go ahead and subscribe to the channel so that you become a member and also motivate me to do more of these videos. See you in the next video. We are going to talk about time zones. See you there. Ciao.